Hi guys, my name is Vineet, and in this tutorial we're gonna talk about how to reverse a simply linked list. So let's get started. Now as you can see, we have already created one simply linked list with some dummy data nodes, and we're gonna perform reverse operation on this list. So after performing the reverse operation, the first node of this list will become last node and last node will become first node, right? So likewise, second node of this list will become second last node, and second last node will become second node of this list. So likewise we will be keep doing for another nodes as well. And after completion of reverse operation, the newly constructed reverse list will be something like this. Now you can see the first node of this list is 50. So earlier 50 was the last node of this list here, right? The reference of 50 was pointing to null, but right now this is the first node of simply linked list and head is pointing to this node, and reference of 50 is pointing to 40, right? So here the last node of this list is 10, and the reference of last node is pointing to null. But before performing the reverse operation, this 10 is the first node of simply linked list, right? You can see here, and head was pointing to 10, right? So after completion of this operation, it will looks like this, right? So you can see head is pointing to 50, and this 10 is the last node of simply linked list, and reference of last node is pointing to null, right? So this is a graphical representation discussion. Now let's get started with backend code. For that, I have already created one class with name reverse linker list. So inside this class we're gonna write one method which will be taking care of reversing the simply linked list. So let's get started now. Private void method name will be reverse without any input parameter, and we're gonna create one head of node type. So inside this reverse method we're gonna take a help of a two-pointer approach here, which will be helping us to reverse the simply linked list. So let's declare those two pointer first. Node, the first pointer will be previous and the second pointer will be next. So initially both pointer will be pointing to null. So we're gonna use while loop to iterate each node of this list. Okay, now let's create one linker list to demonstrate how we are going to reverse this this list. 20, 30, 40, 50, and the 50 reference would be pointing to null. So as we have created two pointer, so let's create those pointer here as well. Head, the first pointer is previous, another one is next. All right, so head will be pointing to the first node of simply linked list, so it's pointing to 10, and previous and next initially both will be pointing to null by default, right? Now what we have to do here is we just have to reverse this list, right? So let's create reversing order here. This should be 50, 40, they should be 20 and 10, right? So this is actual and this is the output of list. Let me give output here. Output, okay. So you can see, right, this is the first node of simply linked list, and after performing the reverse operation, this first node will become last node, and the reference of this node start pointing to null, right? So how we are planning to do that? We just reset the reference of this first node to null, right? So how we are planning to do that? Head is pointing to this node and head next is this, right? So we have to make sure head next should start pointing to null instead of pointing to this node. So we're gonna do that. Head next should pointing to null. Right now previous value is null, right? So instead of passing null here, we can pass previous, because previous is already holding the null. So now we break the link between these 10 and 20, and 10 reference is pointing to null, right? So we have done one node reverse, right, like this. Now but you can see we lost the reference between 10 and 20, right? There is no any connection between 10 and 20 and there is no any reference also which will be help us to access second node. So this would be a problem. Now how we are planning to reverse the remaining nodes, because there is no any reference which will be pointing to this node, right? So to do that we just have to take a help of next pointer. All right, so that's why we are using this next pointer. I hope you are aware of now why we are creating this next. So we are creating before resetting the link between any of the node, right? Either it could be 10 and 20 or 20 or 30. So before resetting these reference, we are preserving the reference of next node. That's why we are using next here. So let's do that. Next is equal to head dot get next. We have preserved this reference in next variable. Now we can reset, right? So next is start pointing to with this line, right? Next is start pointing to wherever head dot get next is pointing. Head is pointing to this and get next means 20 node. So next should start pointing to this node, right? Second node. Now let's put this top of the first list. Okay. Now head is also next is pointing to head dot get next means this 20 node. So and now we can perform this operation. We can reset the link between 10 and 20. So that we have done already in this line, right? Now another part is this 20 reference should not point to 30, but how we are going to do that? So we have to move head pointer here and previous pointer also here, right? So the previous should start pointing instead of pointing previous to null, we should make previous to point to wherever head is pointing, right? So that in next iteration we can access these nodes as well, because we have to make this 20 reference here, right, to start pointing to this. So we should have and some variable where we will be resetting the reference of 20 to that variable. Now as we have preserved this next, right, means next reference in next variable, likewise we have to preserve this reference also, so that we can make 20 reference to start to that variable, right? So previous will be helpful for that, to preserve the reference of previous variable, previous node. So now you can see we can do that with previous is equal to head, right? So wherever head is pointing, previous will start pointing to that node. So now it will no longer pointing to null. Okay, now previous is pointing to previous node, right? Now we have to move head next, so that we will be reset the link between 20 and 30, because we have already done with 10 and 20. Now the next will be 20 and 30. So let's move head one step forward. So that we will be doing using head is equal to next. So next, wherever next is pointing, head will start pointing to that here, right? Now head and next is pointing to 20 and previous is pointing to 10. So we have a reference of previous node, we have reference of next node, right? Now you can see this 20 is pointing to this, but in next iteration it will be start pointing, right? Now let's go for next iteration, right? Now we are checking whether head is null or not. It's not null because it's pointing to 20 node. Now what we are going to, the same operation, head dot get next means head dot get next is 30, right? We're gonna break, I mean right now we're gonna preserve the link which is pointing to 30. So we are preserving that in next variable. So head dot get next means this next will start pointing to 30. Let's move this, right? Now we're gonna reset this link, head dot set next. So right now head is pointing to this node and head next is pointing to 30. So now we have to reset this link. Okay, the reference of 20 should start pointing to 10. So how we are going to connect to 10? So we have to use the help of previous, because we have one previous variable which is pointing to 10. That's why we are using previous here. I hope you are aware of now what is the use of previous and next, right? Now let's do that. So head dot set next to previous. Head is this, right? And set next to previous means head reference should start pointing to previous, that is 10. So 20 reference start pointing to 10. Instead of here, Control X, we are passing this here, right? Now here also we can demonstrate that previous is pointing to 10, right? PREV, right? And another one is next is pointing to this. Next is pointing to an XT. Okay. Another one is head. Now head, we have moved head to this side. So head is here now, HT. Head is always point to this node. I mean, in this iteration, head will always point to 20. Even we are moving this to this side here, right? From here to this side, but head will be pointing to 20. In next iteration, it will pointing to some another variable. Now you can see there is no any link between 20 and 30, but we have one reference. Using that reference, we will be able to access this node, right, which has data value 30. Now we have done this resetting the reference to previous node. Now we have to move previous to wherever head is pointing, right? So previous, we will be moving previous wherever head is pointing. So let's move this here, right? So it start pointing to this 20 node. Now we have to move head also, so that we can reset link between 30 and 40. Let's move head to wherever next is pointing. Head is equal to next means let's move head wherever next is pointing here, right? Now this will become previous node because 30 should start pointing to this. That's why we are moving previous also. And in next iteration, we will be checking whether head is null or not. It's not null. We're gonna again perform the same operation. We're gonna preserve the link of next where head next. So head is this 30 and next of head is this 40. So let's preserve the reference of this node. I mean reference of 30 which is 40, right? So using this line, next is equal to head dot get next. We will be moving next pointer one step forward and it will start pointing to 40, right? And now we have preserved the link reference of this 40 node. Now we're gonna reset the link of head. Right now head link is pointing to 40, but it should start pointing to 20, and we're gonna take a help of previous, right, to reset the link of 30 node. So 30 node reference means head dot set next should start pointing to previous. So that is what we have done here. Head dot set next to previous. Previous we have this. So let's move here. Head we have. Sorry, I forgot to move head here. And previous is this, right? 20. So head dot next means 30 next should start pointing to previous. Head dot set next, head next start pointing to previous. Previous is this, so this will start pointing to here, right? So previous is here only, previous is 20 only, and head was, you can see head is 30, right? So it should start pointing to here, and next is 40, right? It's 40 here. Now you can see there is no any link between 30 and 40, right? So we have done this operation. Our head, this is a head, right? So 30 start pointing to previous, means 30 start pointing to 20. Here you can see, right? 30 start pointing to 20, means it is start pointing to previous. Now we have to make this previous wherever head is pointing, we have to move this. So previous is equal to head, let's move this, and head is equal to next. We have to move another node as head. See, next node we are making as head, so that we can break the link between 40 and 50, and 40 should start pointing to previous node, right? In next iteration we will be checking whether this head is null or not. So it's not null. Again, using this line, we're gonna move one next pointer one step forward, right? And it is start pointing to last node of this list, right? And we have preserved this this node, right? We have variable which is using that we can access this last node, right? Now we can break the link between 40 and 50. So we are doing this in this line. Head dot set next to previous, right? Head we have here, and we are setting the next of head node to previous. Previous is this, means this 40 should start pointing to 30. Okay, so that we have done it here. So now 40 should start pointing to, right now next is, sorry, I forgot to move next here, and previous is 30. Previous is 30 and head is 40. Head is 40. So now this 40 reference should start pointing to 30, right? This head reference should start pointing to previous. So we have had 40 and previous we have 30. So let's move here. Previous we have 30 and head we have 40, right? Don't forget to move these pointers. So head is this and previous is this, right? Now we have break this reference, right? And it is pointing to 40 is pointing to 30 to previous, right? You can see it here. We are demonstrating these so that it will give more clarity, more visibility. So now we have reset this link. Now we have to move previous previous pointer wherever head is pointing. So head is pointing to 40. Let's move previous to 40 as well. Now we have to make another next node as head node. So let's move that using this line of code. Head is equal to next. So it will start pointing to wherever next is pointing, right? Now is in next iteration, we're gonna check whether head is null or not. Right, head is null or not. So head is pointing to 50, right? It's the last node of this list. So inside this we will be moving our next pointer one step forward. So we are assigning head dot next, means head is this and next of head is null. So next should start pointing to null, right? We are moving this one step forward, right? And next, now we have preserved link of this here, right? Now we can break the link between 50 and null, right? We have to assign this head node to this 50 node to 40, means head dot set next to previous. So head dot set next to previous. Now we have to break the link between these two. So let's do that. we will be doing using this line of code, and previous is pointing to 40 and head is 50. So head dot set next means 50 reference should start pointing to previous. So previous we have 40, so head will be start pointing to here, right? And next was pointing to null. Sorry, we have to delete this. Head was pointing to null, right? And sorry, next was pointing to null, and head is pointing to 50 and previous is pointing to 40, right? Now we have to move our previous pointer wherever head is pointing. So previous should start point to 50 because head is also pointing to 50. Now we have to move head one step forward, means wherever next is pointing, head should start pointing to that node, means head should start pointing to null. Now in next iteration we will be checking whether head is null or not. So head is pointing to null, means we are expecting head should not be null, then only we will be executing these while statement, right? So this condition will become false because head is pointing to null, right? Now it will exit from this loop and we just have to move our head, right? So right now head is pointing to null here, right? So we have to move this head to this node, right? So that it was pointing to here, right? Now head should start pointing to this node. So we're gonna do that. Head is equal to previous. So previous is this, right? And head is pointing to null. So what we have done here is we are making head to previous. Now head is you know the convention of syncly linked list, right? Head is always point to the first node of syncly linked list, but it was pointing to, in our case after reversing of syncly linked list, it was pointing to null, right? So we have to make head to start pointing to first node of syncly linked list, and we are taking a help of previous. So wherever previous is pointing, right, wherever previous is pointing, head should start pointing to that node. So that's why we are doing it here. Head is equal to previous, so it will move to wherever previous is pointing. So using that we have reversed this list, right? So you can see head is pointing to here, right? And there is null, so null will no longer available, right? Now let's write main method to test this logic. So let's create a object of reverse linker list class, that's the current class, new reverse linker list. Now let's access list dot, we have to create nodes first. So as we discuss here, this will be the output, right? Okay, let's delete these. Now there is no use of, because we have done the logic, right? Now let's create multiple nodes. First is equal to new node with some dummy data. Now let's pass 5 nodes. This will be second, third, fourth, fifth. Let's give unique data value to these nodes, 30, 40 and 50. As we discussed, we have list of 5 nodes with unique data value. Now let's connect these nodes together. So let's dot head start pointing to first, right? And first dot set next to second, and also second dot set next to third, third dot set next to fourth, and fourth dot fourth dot set next to fifth, right? And there is no any node next to fifth, so reference of fifth will be pointing to null, right? Now let's print these nodes before performing the reverse operation. So I have already created one class simply linked list. Inside that we have one display method which will be taking care of printing all the elements of simply linked list, and display method is expecting head of input, right? So let's run this now. So you can see we have node with data 10, 20, 30, 40, 50, right? Now let's test our reverse operation. So let list dot reverse, and again after performing the reverse operation we're gonna print the same list again, whether it got reverse or not. So you can see here output we have here. So let's verify this output with the output which we had discussed, right? This first line is output, right? So let's print, let's keep our output here. Now you can see the reverse list output is 50, 40, 30, 20, 10, and 10 reference is pointing to null. So before performing the reverse operation, the 10 was the first node of simply linked list and 50 was the last node of reference, and head was pointing to this 10, and last node, that is 50 reference, was pointing to null. But now after performing the reverse operation, 50 become first node of this list and head is pointing to 50, and this 40 become second node of this list, but it was the second last node of this list, right? So, and 10 reference is pointing to null, right? So we have done this program, guys, and it's working fine. So thank you so much for watching this video.